Everybody's leaving.
Did you pause the video?
All right, is that any better?
Did you pause the video?
Yeah, I paused it.
Oh, okay.
Is
Okay.
it coming in any better? Let me turn it back on and see. Miss Roberts, is it coming in any better? Let me, what?
I can see it now.
Okay, good. Anybody else? Okay, keep me posted. I'm trying to, Miss Already, I can't see anything. All right, I'm gonna bring you back in, Miss Already. Hold on. I'm sorry, I ain't never had this trouble with the video before. Y'all know what it is. It's them damn Russians, I'm telling you. Let's see, Already. Okay, I'm gonna play it for a few minutes and then check back in, okay?
Okay, I can see the screen now.
Good.
Dying.
Somebody's trying to do something. Hold on. All right, Mr. Hoyt says that this is free. Go ahead and go to that if you can't pull it up. I'm sorry. But we're going to have class after the video, so I'm sorry.
I mean, I have a site where I can watch shows for free.
Okay.
Are you showing
Just
the
watch
whole?
it and we'll come back to it.
All right. Are you watching the whole episode?
Stuff Florida I don't like about the show. It takes off, goes into this. Say again? Oh yeah, I've watched all of them just about. The only thing I don't like about the show is it takes off too much on rabbits. It takes off on these personal moments, and nobody cares about that. If you're a math person and you like watching it because of the math, you care less about the other stuff. You know what I'm saying? You're very analytical. You're not caring about the soft, squishy stuff.
Hey, Hubert. Hubert. Hello. What the hell?
I think you've got some good eyes if we can see a hula dancer on the.
Hubert.
Yes.
Call us back when you're done with the video.
Okay, will do.
Okay, and yeah, just do that. Just do that.
That's the only thing I can suggest is just play it from that free website. It's called Traffic. It's on the board right now. Traffic. It's the third episode the third season, fifth episode. Traffic, and just watch it right quick. Fast forward through the stupid parts, and then come back. I'll call you back.
Yeah, just call us back when you're done.
Okay.
All right, bye.
Not a very high-powered rifle to just go in and barely go in. It is 30-06, a little bit of watermelon. Maybe a 22. With a hula dancer. First of all, what is random? Everybody has the what? Remember the first unit? Are you on drugs? Comes from my cousin Benny. Are you on drugs? Everybody has the same what? Probability of being picked. All right, that's why they keep talking about this randomness. Now, you could take something that's very random and you can find a pattern. Okay, that's what they were talking about a while ago with the raindrops, and they were talking about what do you get, the MP3 player. If you've ever played an MP3 player, just played it for like 24 hours, you start to pick up on patterns. And that's human nature for us to look for patterns. Some of us analyze too much. And I'm just saying this because my father was very good about people. All right? He could tell a con artist from a mile away. And he could tell somebody that wasn't telling the truth a mile away because he analyzed people. And he did that. He had that. Some people call it a sixth sense. He had that. And I guess I'm still trying to get that because I analyze everybody I meet. Everybody I meet, I analyze. And I say that I notice things. Do they do this too much? That usually means they're nervous about something, or they do it real loud. That means they're mad about something. So I watch people like during meetings, and if they're doing this or if they're doing this, you know, some people call it people watching. I do that too. We try to find patterns with everything we look at. So that's why they're having such a problem with this, because it's so random. If you can't go and find a sequence or a pattern with randomness, then you go the other way and say, well, this is too what? Random. And that's what they're talking about. Some of y'all might not remember him, but he was the head elf on Santa Claus. Yeah. Fibonacci said that. Fibonacci said everything is related to each other. Now all they got to do is cross-represent with hooligans. And what is he going to do? Okay, we're not talking about math here. We're talking about just common sense. Why do you run away from the police?
Because you got a pocket full of dough.
Why do I ask that question? No, No, y'all are missing my whole question. Why do you run? It's not like you're going to get away.
They know they're gonna get arrested anyway, since they got warrants. That's what it is.
The by the time you snatch the bag.
Maybe that's what they're doing. Maybe they're, I don't know. I just don't understand the whole concept of running.
You know
If the
he's
police,
not
if the
guilty.
police came up to my farm or came up to my work and I'm standing there and they ask Tim Bowen downstairs, I need to speak with Hubert McClure, and he points to me. Do you think I'm gonna take off running?
But you're not a drug dealer.
Yeah, warrants.
But the whole point is, why are you gonna run? Because all they're gonna do is get a helicopter and they're gonna catch you eventually. Why do you run?
I'd rather be carried by 6 and dead by 12.
Oh, be quiet. This guy does not look like.
I mean, he's like barely
Does this
alive.
guy does
He's
not
like
look
Shelby.
like he's a track star from high school, okay? Look at him. He's got a skull.
He's not guilty.
Good movie. Jack Nicholson and Adam Sandler. Oh God, it's good. Be a rough way to die with a cinder block. You're talking, how much does a cinder block weigh?
They're like 40 pounds, aren't they?
I don't know. No, they're about 10 pounds. Take 10 pounds, you multiply that by 60 miles an hour, 60 miles per hour. Well, 60 miles, you're going to have to, feet per second, miles per hour, that's going to be divided minute, feet per second. Somebody take a calculator and multiply 60 times 3,600 and divide it by 5,280. You got that?
It should be 30 to 35 pounds.
Did you calculate what I told you?
You start with the wrong number.
60 times 3,600 divided by 5,280. I'm sorry, what? Feet per second. All right? You're talking about probably around 120 pounds of force hitting you at 60 miles an hour. Can you imagine that?
No.
You ain't gonna know it anyway. It ain't like you're gonna sit there and go, oh, my head. You're gonna be dead. This guy's just crazy. acceleration. I think whoever's doing it is doing it on purpose, doing the different methods on purpose.
I do.
You're forgetting all about the holiday. You know where darts came from? It was a way for archers to practice while they were inside. Hope y'all knew that. I record typically. I don't know. When I was in civil engineering, I had to take a class called traffic engineering. You think you go in there and study about cars and trains, and it wasn't nothing but another math course. You studied math in the traffic engineering, and you were studying math, algorithms for red lights, ballast calculations for trains, for railroad tracks, ballast calculations for interstates versus two-lane highways. There wasn't anything about roads. They did. That one was coming toward her.
just go and bringing down doors on whoever. Oh, that's not it. Let's go do this.
Okay, you got 15 Glock 9mm pointed at you, all right? And they tell you, turn around and put your hands up. What do?
Whoa. Hey,
You turn around and you put your hands up.
No.
You don't sit there and go, what is this? What do you want?
Hey, you wait till they grab you, then claim police brutality.
I don't feel sorry for anybody that gets 15 bullets shot in them because they didn't follow what? Directions.
Like you were told literally 100.
Oh, these are all messed up. Okay, put your guns down. I'm sorry, but I don't think that man can shoot a rifle. That's exactly. Thank you. The hula dancer. Any other way to change the red light? All right, now I got a question. You go out of your way to plan to kill people on the interstate. Why are you going to worry about red lights? Honestly, why?
Ford F-150. I didn't see a hula dancer.
Did y'all see a hula dancer?
Asset placement. That hurt. Did that not hurt? What is that? There she is. See?
You don't have one police car, you have two police cars, one in front of you, one behind you, and you're on a bridge. And you're going to try to get away.
Three. Four.
I don't care what you say, that rock will hurt.
Like this.
Yeah, this is boring. I don't know why they.
I don't know.
So, we're talking about randomization. We're talking about, so let me get back to I got to get back to them. The ones that stayed. We had some that stayed. Okay, good. Let me add the ones that didn't. We're going to talk about cause and effect. I drink too much wine, I have to pee. Y'all seen Matrix 2? Huh? Y'all ain't never seen Matrix 2? Movies. Now, let me guess, y'all only watch the movies that are the latest movies. Never watch any good movies that's in the past. Right? Okay, forget it. You're not going to talk
I
to
don't
me.
have a TV.
You don't have a TV. Okay. Well, that's good. I tried to add. There we go. What? What'd you say? That would be very painful. Oh, not having a what? Who else? Who else was here? Somebody name somebody else. Thanks. Is Miss Moore there? Miss Moore. Oh yeah. More, Sherry Moore.
They like search the whole city in like 30 seconds for all this data.
Yep. And what'd you say? What was the other name? Okay, hopefully y'all can, I hope I got most of y'all. I'm sorry if I don't. I don't know what was going on with I think there might have been too many people. That's what Miss Roberts said, and I believe that would probably be true.
So random.
Yes, random. Everything is random. If y'all can think of anybody else that I'm missing, Miss Smith cannot be reached. Let me try Miss Moore again. And I'm going to try Miss Smith again. Okay. All right. So if you look in your books, you will see in 4.1 and I think 4.2, because I usually teach this after we start probability, I usually teach the cause and effect. Now, if you watch the Matrix, the second Matrix movie, you'll know what I'm talking about. The second Matrix movie, they're going to find the key maker. Well, the key maker belongs to this other guy, and the other guy, when they go meet him, they're in this French restaurant, and they talk about cause and effect, correlation, cause and effect, and he's got his French accent, and he goes, correlation, cause and effect, is simple. I drink too much wine, I have to pee. And that's cause and effect. All right? And some of y'all are going, what are you talking about? Oh, well. Correlation means that if something is happening, it's causing something else to happen. Let me give you an example. Which kind of vehicles get lowest gas mileage? V8. Nope, that's not the answer I'm looking for, but you're right. That's an engine. Okay? Trucks. Okay? Keep going. That's a make of a vehicle. I said, what vehicles? Huh? Okay, you got the first part right. The heavier the vehicle, the lower the what? Gas mileage. Cause and effect. That's cause and effect. I drink too much wine, I have to pee. Right? What was this 4.1?
Yes.
Okay. So
Weren't we on 5.1?
yeah, we were on 5.1, but I always go into probability, and then I take a step back to cause and effect, because that kind of merges the two together between statistics and probability. I always do the first section of probability first. All right? Now, only thing you're responsible for in this section is what the scatter diagram looks like, scatter plot, and what it tells you. So let me find you a scatter plot. There's a scatter plot. Now, what do you do with a scatter plot? The first thing you do with a scatter plot is you take a handy-dandy whiteboard, your virtual whiteboard that all of you have in your pocket, and you make it transparent, and you draw a line on the scatter plot. Now, how do you draw the line on the scatter plot? Well, there's two ways. One is to do it by eyesight. The other is to do it by mathematics. We don't want to talk about the mathematics part because that's called least regression, all right? And you don't want to do that. So it just takes too long. Huh?
Is that like least squares?
Yeah.
That's all.
You're not going to say slope, are you?
What'd you say?
You're not going to say slope, are you?
Yeah, pretty much. Why?
Out, done.
Okay. See ya. I don't know who said that. Who said that? Who said that? Hello? Okay, don't leave. Who left? Who said that? Did anybody leave? Miss Roberts, did you say that?
Yeah, it was me.
Okay, it's not. Okay, it's not that hard. Okay, let me show you. All right. First of all, I mean you did have a good teacher, okay, in algebra. That's why you don't understand it. All right. There we go. There's the line. Now, why did I draw it there? Well, I just eyeballed. That means no mathematics involved. I just eyeballed where I think the least squares line would go. Okay? It's kind of like connecting the dots, but you don't connect the dots. You put the line in between where you think it'll be. Now, is your line going to be exactly like my line? No. But it will tell you whether you have a positive correlation or a negative correlation, and that's based on the slope. Okay? Now, you ready for this, Miss Grant? Because I don't know if you can handle this or not. This is some real difficult mathematics. You ready?
I'm going to try.
Okay. Now, if all teachers would teach slope like this, there wouldn't be any problems. All right. Which way do we read?
From left to right.
Unless you're from the Middle East, most of us read left to right. So that means that whenever you read a line, you read it from left to right. And what you always do on the slope line is you go to the left-hand side, you put a little car, and you ask that car, and you ask yourself, what is that car doing as it goes from left to right? What is it doing? It's going uphill. So therefore, you have a positive what? Positive slope. Draw a car, left-hand side. What is this car doing? It's going downhill. Therefore, it's a what slope?
Negative.
Negative slope. What is this slope doing? Zero. It's a horizontal line. Horizontal line slope is equal to 0. Or you can say the car is not doing anything because it's sitting. So there is your positive correlation. That might have two. Correlation may have two L's in it, I don't know. Negative correlation.
If the line was going up and down, it's, you don't have slope.
What?
The line's
That'd be undefined, therefore does not exist. Therefore, you don't have any, correlation does not exist. Horizontal slope means the correlation is constant. Or no correlation, whatever you want to say. None. No correlation. So which one looks like the heavier the car, the less gas mileage? Heavier the vehicle, less gas mileage. Gas spelled with two S's. I don't know how to spell mileage, so it's one of those weird words. M-I-L-A-G-E, is that right? I thought I want to spell it different. That's what I thought it was. All right, here is the weight of the car or the vehicle, and this over here is the what? Gas mileage. So what's the gas mileage doing as the car gets bigger? It's decreasing, which is called negative correlation. All right. Now, anytime you want to find the slope of the line, it's real simple. If you want to calculate, the slope of the line is equal to x of 2. I'm sorry. This is not right. Thank you. Y sub 2 minus y sub 1 over x of 2 minus x of 1. And a lot of people usually look at that and go, I have no idea what that means. Well, given 2 points, 3, 2, 4, 4. Which way do we read? So this is x of 1, this is y sub 1, this is x of 2, this is y sub 2. And I tell students to use parentheses when you plug in. Slope is equal to parentheses minus parentheses over parentheses minus parentheses. Now you just plug in what?
Plug it out.
That's it. 4 goes here. What goes here?
I didn't have to remember what, no, that's it.
What goes here? 2. What goes here? What goes here? And the slope of that line is 1 over what? 2 over 1, which is 2. And that's how you calculate slope. So, it's not, Miss Grant, it's not difficult to figure or calculate the slope, but it is.
Well, I mean, that looks easy, but when you start adding in, like, double fractions and imaginary numbers and stuff, and
No, I'd have to see the question, but 90% of the time, this is the way a slope question is asked.
I can do this.
The only other way is like this. And I give you this point is 0, 5, and this one is 4, 0. That's another way. In other words, they're on a graph, and you plug the numbers in there. Well, if they don't give you the points and you have to find them, it has to be on graph paper. It has to have all the little, the little things like this. It has to be so you can actually find the point. And I don't do that because I can't. I'd have to actually bring in a piece of graph paper to do that. So that's how you find the slope. Now, there is a way to find the correlation, but I don't test you on that because that's a second semester probability course. So that's how you find the correlation. Let's go to another one. Let's see if they got one on this page anywhere. There we go. Look at those, I mean, write down the page number. That is page 179. And I'll only ask you the ones that you're responsible for. Take your handy dandy straight line maker. What kind of correlation is this? Very positive. And this one's very what? Negative. But these are linear because they're a straight what? Line. You could say that this is a positive correlation like that, but it's nonlinear because it has a curve in it. This is constant because it does not have no correlation. It's constant. This one, I ain't even going into this one because this is it's nonlinear. We're not even going to worry about that one. Okay? So right now, as far as correlation, you just need to be able to draw a correlation and tell me if it's positive or negative. And I think you can do that without any problem. That right there is constant pretty much. Got a little bit of correlation, got a little bit of increase, but not much. Now, they tell you in this section how to find the correlation coefficient. There it is. Now, I'm going to tell you something. You're talking about some tedious math, even on the spreadsheet right here. Now, you can do it on a calculator a whole lot quicker. And I just tell students, if I do ask you, it'll be on the calculator, because I'm not going to ask you to do that, because I tried to do it one semester, and it was just a pain. But about a half a page of calculating on the Excel spreadsheet just to get that formula. And I told students I'm not going to ask you to do that. Right? If it takes me a half a page, it'll take you 2 pages. So we're not going to do that. Unless y'all want to. So y'all want to? Mr. Ellis says he wanted to.
I smell mutant.
Okay. Here's some more examples. Positive correlation, positive correlation, positive correlation, negative, 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 constant, nonlinear, which I'm not going to test you on nonlinear. Positive correlation, negative correlation. I'm not asking you to do that. But somewhere in here, see, I'm not going to ask you. Somewhere in here, there's a way you can do it on a calculator, right here. So, hold on. It's on here somewhere. I'll find it in just a minute. There's a positive correlation. So far, I don't see anything else that's testable except for the graphs. Negative correlation. That's 4.1. I just want you to be able to tell what the correlation is. I'm not going to ask you on a test about the correlation coefficient. If I do, it'll be on the calculator, and somewhere in here it shows you how to do the calculator. I'll find it and we'll go over it, but right now I can't find it. That's 4.1. Do we do 4.2 also? Look on the outline. That's that sheet that I told you to bring to class with you every day because it was important.
When did you say that?
No, you wasn't here. I didn't tell you. I didn't even send it to you. Ooh, finding the equation. We can find the equation of a line. That's real easy. There we go. Okay, now here is a good example of finding the equation of a line. All right, I want to see how much y'all remember out of your algebra, and I'm going to put 2 formulas on the board. And if you can't remember, just basically tell yourself what? You're a failure. Good. We're starting to learn.
Smokestacks on a Prius.
What? What'd you say?
Smokestacks on a Prius.
Yeah, exactly. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Did I tell y'all about the black Dodge with the rusty pipes on it?
Yeah, 10-foot tall.
Hadn't seen it since. And y minus y sub 1 is equal to m times x minus x sub 1. Which way do we read?
Left to right.
So this is x sub 1, y sub 1. This is x sub 2, and y sub 2. Now I want you to calculate the slope first.
I know why you hadn't seen it. Because you're surrounded in a cloud of black.
Yeah, that's why. That was one ugly truck. Let me tell you. You ever seen the movie Duel? It was written by Stephen King a long time ago. It's about this car that's on this long highway, and this truck chased it, tried to kill him. And the whole movie, they never said a word. The whole movie was just about them chasing each other. Well, this truck, this black truck with the rusty smokestack, looked like the truck that was chasing this little man. It was ugly. Okay, what goes here?
275.
275. What goes here?
258.
What goes here?
105.
See, they ain't all smart.
You're just saying that.
Yeah. So I'm building you up so I can kick you in the gut. What's 275 minus 260? 15 plus 2 is 17, right?
Yes.
You'd be surprised at how many people can't figure out what I just did. 105 minus 100 is what? 5 plus 1 is 6. And 17 divided by 6 is 2 and 5, 6. Right?
Yeah.
And 5, 6. If I wanted to do it right, let's say 5, 6, that would be 50 over 60 divided by 6. On top and bottom would be 50 divided by 6. 50 divided by 6 is 50 divided by 6 is 8. 8 times 6 is 48. I'm thinking out loud.
You're getting close. I can tell you
8
that.
tenths, 2.8. What'd y'all get?
2.83.
Okay, I'm getting that. 2.83. There's your slope. Everybody with me?
Yeah.
Okay, now you're going to go down here and you're going to pick a point. I'm going to pick this first point. Somebody tell me why I'm going to pick this point right here instead of that point. It's closer, meaning it's smaller what?
Numbers.
Numbers.
Yeah.
Smaller numbers, Kiss method. What's the Kiss method? Keep it simple. Okay? So I'm going to use smaller numbers. You can use the other numbers if you want to. You'll have the same thing. So this is x sub 1 and y sub 1. Y minus parentheses equals 2.83 times x minus parentheses. What is y sub 1? 258.
Yeah.
And what is x sub 1?
199.
Now you just solve it. Y minus 258 is equal to 2.83x. Somebody multiply 2.83 times 100. It's going to be 283. Probably going to knock off a couple. 281 something. What is it?
I got 280. But I need to be 17 over 6. 17.
That's fine. What'd you get?
280.5.
281. And then y is equal to 2.83x minus 281 plus 258. And somebody tell me what negative 281 plus 258 is, and that's y is equal to 2.83 x minus what? Huh? 23? And that is the equation for this line. See there? You're not a failure.
Hot dog.
You are, though.
Yes.
So if you wanted to know where this line crosses the y-axis, you plug in 0 for x, and you're going to get negative 23. So it crosses the y-axis at negative 23 when this is 0. So you're talking about 99 to 100, that's 1. So you're talking about way over here is 0. So this sucker's crossing at negative what? Negative 23.
What does that show?
Well, it shows your slope, 2.83, and it shows you that the y-intercept is negative 23. It also shows you at 280, what am I going to hit at 280? What's my x value going to be at 280? Well, plug it in here and solve it. It's a predictor. Once you find the equation, you can predict based on cause and what? Effect.
Correlation.
Correlation.
It's not too random.
Okay? It's not too random. Exactly. Y'all starting to put 2 and 2 together and get 6.
Crushing this thing.
I think I deserve it.
You deserve an A.
You participated.
You participated. Question. Now, if you really want to get confused, just do the least squares. And then you'll be totally like
I have fun.
lobotomized.
Yeah, that's some intense math.
And it's very tedious. There it is right there. Now, I just want you to look at it. It's on page 196, and I want y'all to make a note of it. I want you to look at it. And all I want you to do is just look at what they're doing. They're finding the middle line between these points. Okay? So if I was to take a handy-dandy straight line maker, I heard that yawn. You're not supposed to yawn in here. Okay? Don't yawn. And I draw a line here. And I draw a line here. And then I draw a blue line.
Is there another homework?
No, I don't sign them. At least I don't think I sign them. I don't think I do.
That was awful, man.
It's tedious. Okay, basically I just drew a what? A rectangle between this point and what? This point. And I take my handy dandy line maker, make it red. No, I already used red. Let's make it blue. Aqua. Okay? And between that is a point right here. Everybody understand that?
Yeah.
But they don't want it right there. They want it right here. So you have to figure, and I could add another line across here that's parallel to there, to here. So these 3 lines are parallel. You can transfer this point to here by using the least squares method. Okay? And it's very tedious math. I don't go into it because there's no use in it. Okay? Now, you could actually find the least squares with a calculator, and I'll show y'all how to do that, but it's really not necessary. But that's what they're doing. They're finding the midpoint, and they're shifting it from here to where? Over here, under this point right here. And then they do the same thing here with these 2 points, and with these 2 points, and with these 2 points. So each one, you got a rectangle set up between the 2 points. That's the best way to say it, and I'm not going to go any further on that.
It's really like the average of the points.
That's what it is.
But then what about when it gets curved?
Then you talk about a totally different animal. We won't even talk about that. Okay? Next problem that we need to talk about. And there's the least regression. And they might give you the formula. I don't know if they give you the formula. Yep, by hand. And there it is. I'm not going to do too much. What time's class over? 2:09. Is class over? Is it?
Honestly, couldn't do it.
No, it's over at what, 2 or 2:30?
That's kind of been up in the air since the beginning.
I think it's over at 2:30.
I don't think we know.
All right, somebody tell me. When's it over?
No.
Is it over at 2:30? Are you leaving early? Okay. Here it is. Y'all look here. There's the y-intercept. The linear regression. There's where you find the y, and we'll talk about that when y'all come back. Okay. And it also, somewhere on the TI-84, it gives you the coefficient, and it also gives you the least squared. So we'll go through that Monday. Okay, I'm just showing you 4.1 and 4.2. What's important, what's not. There's the least squared. Yeah, 4.2 is based on equations and least squared. And that's how you do it by hand. Mm-hmm.
I never even heard of that.
Okay.
So,
Yep. It's used to find the error.
yeah.
That's what it's used for.
On the what?
Error.
Error?
Error. Depends on where you're from. If you're not from around here, it's called error. And if you're from around here, it's called error.
It's just like Woodsy Green.
Greer driveway. Greer.
Error.
But if you're not from around here, it's called the Greer driveway. All right. Now, what do you need to do for homework? Nothing right now.
Nothing.
I don't want to assign the 4.1 and 4.2 homework until I'm finished with it. So y'all are welcome to take the weekend off, or you are welcome to finish the 5.1 homework. Okay? Any questions?
Nope.
Not about these squares.
Okay. All right. Y'all need to work on 5.1 homework and wait till next week to work on 4.1 and 4.2. And if you've done 5.1, then you have the weekend off as far as math goes.
Yeah.
Question?